So we'll build up some momentum into today. So cosine A plus B property, can somebody tell me how that goes? Cosine, cosine, sine, sine, A, and then keep the plus or switch it. There you go, minus. I agree. Let's do sine. Yeah. Plus. Agreed. Tan?
Tan A is tan B. 1 plus tan A times.
Well, minus.
1 minus tan A times.
So in theory, we know those are in there. At some point, I'm supposing, I can't prove this, I can look it up maybe and it's true, but my supposition is somebody once upon a time decided to tinker with one of these raw A's. In algebra life, A plus A makes 2A. And if you tinker with that, you would just like by accident create what's called double angle properties. So sine 2A is basically this if we could just combine some stuff. Cosine 2A is what you would get out of this if you just tried to like put some stuff together. Tan 2A is like what that one is if you just put that stuff together. We do the tan one and then we'll work our way back to the top. What would tan A plus tan A be? 2 tan A. The bottom would be 1 minus. Tan squared A. So I'll ask you to memorize that one for tomorrow. We'll end up taking a 6-point quiz, I think, tomorrow. If you know the tan adding property, you sort of kind of already know it. It's just built off of that. How about our cosine 2A property? What do you think about that one? Cosine A times cosine A? Cosine squared A minus? What's that remind you of? With all the squares. Pythagorean. We're going to twist this into a couple different options in a second. I'll come back to that. Sine 2A. What's really true about these two items? They're the same. So we can just go 2 sine A cosine A. Question about how we build a low momentum, turn the old ones into the new ones. What's the old Pythagorean property that had sine squared in it? Agreed. So if I wanted to tinker with this, what would cosine squared equal? 1 minus sine squared. So sometimes this one will get a little bit reworked. This is 1 minus sine squared, like we just said. If you go 1 minus sine squared minus another sine squared, that could be 1 minus 2 sine squared. This is just as good as that. It's not better or worse, it's just different. In a similar way, this could also be reworked to be 2 cosine squared minus 1. Either way, you want to do that, doesn't really matter. Question about the new cluster of properties. So what this could do for you is stuff like, if you had 2 times the sine of 11 times the cosine of 11, it's definitely this property, 2 sine A, cosine A. If these are both 11s, when you step into this world, that could be traded back and forth for just having sine. But if these are 11s, what's this about? That wouldn't be an 11. 22. They're called double angle properties for the basic reason that they double the angle. So if you've got, if I decided to throw you cosine squared 9 minus sine squared 9, launching off of this one, you could trade cosine squared minus sine squared for just a cosine, but it's no longer a 9. Now it's 18. It doubles the angles while you make those switches. Question about that concept? This is one of the reasons why a few days ago I said you have to be careful about always after every trig word having what's called an argument. All the earlier properties we memorized all had x's here. And on the quiz we got a little sloppy about remembering to write our x's all the time. Well, yesterday that started to matter because there were A's and there were B's. And today now there's A's and there's 2 A's. The next day of properties when we go to 3-5 there's a thing called half angles. So you can have X's and half X's. Those little things, they matter. Question about tomorrow, I'd be asking you to basically replicate what's in the box for 6 points. A name is a point, sine's a point, cosine is a triple point because there's 3 of them. Tan is a point because there's a single of them. I'll make sure I'm still on screen here. I think we went off screen for some of that, so we'll do a small rotation that'll probably break our temporary tripod. Zip. Don't touch it. No one look at it or breathe on it. Won't work. Okay, I'll do one from each homework group. So if you want to join me, I'm working from page 88. Tonight you'll work from page 188. So the first group is going to go from 9 to 16. So I'll just do 9. The first group of this will do the same thing the first group of 3-3 did. It's what the first group of 3-5 will do. Describe to you a scenario and expect you to draw like an Oscar having a heap of apples kind of picture. So on number 9 they say draw into quadrant 1. So I did. Then we always make a triangle by going to the x-axis. This angle that touches the x-axis is called a reference angle, making this side the opposite, adjacent, hypotenuse. They tell us sine is 3/5. So if sine is 3/5, who's the 3? Yeah. Who's the 5? H. Who's the A? 4, because 3, 4, 5 is our 5. What we're going to need to run these properties is to identify what is the sine of A, which is 3/5. It better be 3/5 from the picture because we knew that before we had the picture drawn. We also need to know what the cosine of A is. Cosine of A is 4/5. And what they're asking us to do on this number 9 question is find all 3 of these. Sine 2A, cosine 2A, tangent 2A. So if we go to do the sine of 2A, we just have to look for this. We take 2 times the fraction times the fraction. 2 times who for sine of A? 3/5. Times another fraction for cosine of A. 4/5. We math that all together, keeping in mind that's over a 1 if it makes you feel better, and you get 24/27. Something about that. Cosine 2a. I would just grab the cosine fraction but square it. If you grab the cosine fraction but square it,
16
agree, minus, grab the sine fraction but square it,
12, or 9 or something.
agree, math, agree. I'm not going to do any of these properties to do tan 2a. I'm going to do an old thing to get tan. What's our old thing that could get us tan?
Dividing sine and cosine.
Sine divided by cosine. Sine divided by cosine, what's going to happen when we divide fractions? This one divided by this one. Second one flips. Who's going to cancel? 25. You can just put, if the bottoms match, always just put sine's top on top of cosine's top, 24/7. Something about 9, how to do that, or what's being asked of you here in the group. I see one of them that's not a fraction. So if they would say to you, like, the secant is 5. Chalk is baby things. If they said, like, secant is 5, one of the numbers on the triangle would be a 5. How is this giving you another number slightly in disguise? It's over 1. So your triangle would have a 5 and a 1. So. What if it weren't a triplet? How do you get the legs and if you don't know 3, 4, 5 square subtract 3? What if you needed that blockage? Okay, those skills will be afoot in this 9 to 16 zone. They're also going to draw you to some other quadrants. What's going to be a little bit different if we draw to any of the other quadrants other than quadrant 1? What will be true of something somewhere? There's going to be some negatives in it. Question in there, that 9 group. And the second thing we're doing, second homework plot, from 17 to 22, we're trying to solve equations again. So we did this a couple days ago. I made up an example yesterday, which you missed because you weren't here, but nothing new happened. We were just trying to catch up on homework. For equation solving, first thing you have to do is recognize what property you have. 17 is the meanest one of the group, because I think it's the one of only 2 of them that it's not a perfect match for property. This isn't perfect compared to any of these. But which one does it most look like? Sine 2a. But we can't do anything until we get to that point. So we need to work this equation out a little bit. Now, algebra life, we remember, whatever you do to one side, do the same to the other. So what did I just do to this side? I did it. I divided. Because this stuff is all trying to multiply. So I just divided by 2. So I need to divide this by 2. That's going to happen to you on 17. It's going to happen to you on 18. None of the other ones do a weird thing like that. The rest of them are just straight out a good fit for the problem. So let's make an exchange. This is this. Just instead of A's, I have X's. So I make my property switch. So, question about that?
What did you? Oh, you just made some. Okay.
You see it?
Yeah.
Anybody? Then what are we doing? We're trying to solve for the X. How are we going to do that? What gets rid of sine? Inverse. So we're going to do an inverse. When we do an inverse, that gets us just a plain old 2x. And again, whatever you do to one side, you have to do to the other. If I'm talking about doing an inverse on this, where are we looking for that information? Looking at the chart. Sine, root 3 over 2's 60. Almost, slight lie. If it was a theta, yes, 60, it's an x. Pi over 3. You should briefly consider whether there's a negative afoot, because sometimes there is. This problem there isn't. But as I peek at the homework page, I see they sneaked in 3 negatives out of 6. So half the problems you have to deal with some negatives. But we also have to look at our notes or scan our memory for a general solution or general formula, whatever you're in the mood to call that. How do we build a general formula around sine stuff? 180 minus or pi minus, in this case pi minus. So what's pi minus pi over 3? 2 pi over 3. And then what do these both have? Add 2 pi k. That's a complete mimic of what we did in 3.3. We'll do this again in 3.5. When we solve equations in any section, property recognition, then inverse works with the chart, works maybe with negatives, works with the general solutions. And then you're going to have some kind of an algebra opposite. The 3.3 lesson, you were always adding or subtracting. This, to get rid of a 2, you're going to have to divide by 2. Adding and subtracting we could only do with like terms the other day. Dividing by 2 you can do anything. Anything and everything can divide by 2. So new fraction. Here this division by 2 just kills the 2. Get a new fraction. This division just gets rid of the 2. That's going to be our answer in a second. Theories on what pi over 3 divided by 2 is. It is pi over 6. One quick trick you can do with fractions when divided by 2 is double the bottom. Doubling the bottom divides by 2, if you like that. Another trick that's better in other settings like this one, you can either double the bottom or you can halve the top. It's easier here to halve the top. Instead of 2 pi over 3, it's just pi over 3. So when you go to divide by 2, if the top divides by 2, do that. If the bottom, if it can't, then just double the bottom. But we're seeking answers like this today for that section. That's what tonight's homework is. It does that.
At the start, when you divide it by 2 on the other side, could you make it 2 times 2 sine x plus x and then just do it that and multiply to get there?
So you're saying what here?
2 and then just times 2.
Okay, your issue there would be if you left that as a groove, and there's a 2 there with this as a groove, and the root 3 is still sitting. When you go to look on your chart for root 3, it's non-existent. Because it just wouldn't work on your chart. At this point, you'd have to get that over there for your chart to help you. So you could delay a minute, but you couldn't delay all the way to the end. Something there. I won't have a lesson tomorrow, so this is 2 lessons for the price of 1. The next day's homework, I'm just going to do an example problem of that, and then tomorrow I'll just help you do whatever you're stuck on. But for tomorrow's homework, you can work on the picture draws, often having a heap of apples, work on the equation solves, call it a day. The second day of homework on this that wouldn't be due until next week would be pick a side, turn one side into the other. So I'll clear a little bit of space because I'm getting a little crowded feeling here. Am I still on camera in this corner, or am I if I work this side, am I good, or am I running out of space? Should I adjust?
Yeah.
Adjust it a bit. Audience, sorry. It's hard to be a one-man band. There's some good stuff over there. You could listen to it. You don't get to see it till the end. The last bit of homework, like I said, it'll be pick a side, turn this into that. So Generally, we've more chosen the left, but you should always keep an eye out for more, what side is more complicated looking. You're always better to work from the more complicated looking side. So for this problem, I would start with the right side of number 23, because there's just more stuff there. And then I would hope at some point to somehow turn this into sine 2x. So if we look at this, old ideas, new ideas, anybody have a thought on what's up with this? It's not this property we just learned today. Why isn't it the property we just learned today, although it's close? It's a plus, so it's not that. It's not start off with new. It's start off with old. Conjugate would be tempting, but would take us down a road that it'll be hard to say, I think. Because if we do conjugate and FOIL, we'd be up to like fourth powers, and I don't know how we'll get back out of that.
Is it Pythagorean?
It's Pythagorean. Yeah, on the bottom, we have a Pythagorean property for 1 plus tan squared. What is 1 plus tan squared? Secant squared. So that's something. Then we could go with one of two ideas. Probably one idea is going to flow a little better than the other one. Yeah, reciprocal is going to be your better idea. The first advice I ever gave you is make stuff sines and cosines. If you have a chance, make stuff sines and cosines. So we could leave the 2 and the tan alone. If secant flips, what is secant flipped from? Cosine. But since secant was squared, cosine is squared. Then I'm still following that same bit of advice. Making sines and cosines is always a good idea. How can tan be made into sines and cosines? It is sine over cosine. If it makes you feel any better, you could put that cosine squared over a 1, but that's not necessary. There's a quotient property. How can we simplify this a little bit? Cancel. That would leave one of the cosines from the squared though. So then we're looking at 2 times sine times cosine. And I left myself a perfect amount of space here because how is 2 times sine times cosine, our friend? That's the new properties. I'm going to say double angle. That's my abbreviation for double angle because I don't like to write things. But that's our double angle top property on the list. So again, tomorrow, picture draw and equation solve. 2 days away is a cluster of turn one side into the other. It goes from 23 to 32. As we did this, did we do more of the new or more of the old properties? For this? Like the today properties? No. We did more, like the today properties probably happened like once. It's more of the old stuff we already took the quiz on. So like Pythagorean, reciprocal, quotient, that stuff that we've already tested, that's going to be much more what you're doing. The double angle, I guarantee, is going to come out once, because if it weren't, why would it be on this page? Like that? It's stupid. So double angles are going to happen probably once per problem, twice probably max. That's all we've taught.